Let's go over question number 20 from chapter 7. It says, Barron's reported that the average number of weeks an individual is unemployed is 17.5 weeks. Assume that for the population of all unemployed individuals, the population mean length of unemployment is 17.5 weeks, and that the population standard deviation is 4 weeks. Suppose you would like to select a random sample of 50 unemployed individuals for a follow-up study. We have 3 parts to this problem. First, we need to show the sampling distribution. Then, we need to solve for the probability that this random sample will provide a sample mean within 1 week of the population mean, and then solve for the probability that this sample will provide a sample mean within half a week of the population mean. So what do we know? We know that our mean is 17.5. We know that our population standard deviation is 4. And we know that our sample size is 50. So using all of that, we can now show the sampling distribution. This means that we're going to need to prove that this is normally distributed. We need to show its expected value, its standard error, and draw the bell curve. So the proof that we can use here is that n is greater than or equal to 30, and our sigma is given. So since we proved that it's normally distributed, we can draw the bell curve. Now, the expected value. The expected value is going to just be the mean. So our mean was 17.5, so our expected value is 17.5. We can now put the expected value on our bell curve. Now we're going to need to calculate our standard error. So our standard error is sigma divided by the square root of n. So we have all of those pieces given to us over on the left side of our screen right now. Our sigma is 4 and our n is 50. So if we plug that into our formula, we get 4 divided by the square root of 50, which comes out to be 0.57. So here in part B, what is the probability that a simple random sample of 50 unemployed individuals will provide a sample mean within 1 week of the population mean? So let's put that on our bell curve. So within 1 week, so that's plus and minus 1 week of our mean. So we are going to be looking for the area between 16.5 and 18.5 on this bell curve. How are we going to be able to do this? We need to find z-scores. So we know that our mu is 17.5. We found our standard error in the last part of this problem, which is 0.57. Our x bars, those are going to be the 16.5 and the 18.5. So if we fill that into our z-score formula, it'll look something like this. All right, 16.5 minus 17.5 all over 0.57, and then we do the same as well for 18.5. So we want to fill in all of our z-score formulas, and then we can solve, and we'll find our z-scores to be plus and minus 1.75. So now that we have the z-scores, we can look in our z-score table and find the areas. Now remember, the areas when you look in the table will be to the left of the z-score that you are looking up. So when we look up the z-score of negative 1.75, we are going to get an area of 0.0401. And that's the area to the left of that z-score. When we look up positive 1.75, the area to the left will be 0.9599. So we now have our two areas to the left of each z-score, but we want to know the area between those 2 points. So in order to find that, we need to subtract our two areas. So if we do 0.5 or 0.9599 minus 0.0401, we will get 0.9198. And so that's the probability that this random sample will come back with a sample mean within 1 week of the population mean. So if we take a look at part C, the piece that changes here in part C is that we want to now see what the probability is that this sample will provide a sample mean within half a week of the population mean. So we now want to look at 17 and 18. Those are our 2 points on the bell curve. So how do we find the area between those? We're going to need to find our z-scores again. So our mu is still 17.5. Our standard error is still 0.57. Our x bars become the 17 and the 18 here in this problem. So when we fill in our z-score formulas and solve, we can find that our z-scores become plus and minus 0.88. So now we can look in our z-score table again, and we can find the areas. So the area to the left of negative 0.88 comes back as 0.1894, and the area to the left of positive 0.88 comes back as 0.8106. Again, we're looking for the area between those 2 points on our bell curve. And whenever we're looking for the area between 2 points, we want to subtract our two areas. So we take 0.8106 and subtract 0.1894 to find our final probability answer of 0.6212.